Hi, everyone, and welcome to the first session of Fundamental Statistical Tools. I am Anne,
I am Guillaume.
and we'll be your instructors. So, we may not cover exactly all of the statistical tools. I mean, in fact, a couple of people had asked for mark recapture. We may not cover specifically things you might want to learn, but the idea is that we will cover the fundamentals of statistics and some fundamental principles, and as well as coding in R, so that you should be able to figure it out from there. Like, no matter what data you have or test you have to do, we'll make sure that you should be able to apply statistics and use R to do it for that. So now the first question is why statistics, right? So let's say that you want to figure out something about, all the leopards in the Himalayas, and you go out there and you measure all their lengths and come back, and now you have this cloud of numbers. What do you do with this? This is where statistics comes into the picture, and it can help you figure out things about your population. So the all the leopards in Himalayas is what one would call the population, which is what you want to understand. And the data you collected, which obviously cannot be all of it, is the sample, which is what you will do statistics to in order to gain knowledge and understanding about the population. Now, there are two main types of statistics, that's descriptive statistics and inferential statistics. In the first session, we'll go through some of the fundamental types of descriptive statistics. Descriptive statistics are used to help you understand the population that you have sampled. So, for example, using this set of data, I can figure out what's the average size of the leopards in the Himalayas and things like that. Whereas inferential statistics is meant to help you draw inferences. For instance, if you wanted to compare two places and see if the leopards from one area are bigger than the other. And now we'll move on to the types of data. So you will encounter various data types through your sampling and research, and different data types will be handled differently by stats. So first, we have the categorical data. Within categorical, we have nominal. So this would be just categories. For example, hair color, brown, blonde, or black, or male versus female. There's no hierarchy here. It's just different types of data. Then we have ordinal data. This would be the type of data you gain out of, let's say, a survey. So if you ask someone how they feel about something from very bad to very good, the data is again categories, but there's this vague sense of hierarchy there. There's a very bad being the lowest to very good being the best. And but however, you can't tell whether the increments are equal. It's just this vague hierarchy. Then we move on to numerical data, which is usually the kind of data we deal with in research. In this, we have the interval data, which is, for instance, which is data which does not have a true zero. For example, temperature measurements of degree centigrade or degree Fahrenheit is interval data, because there is an arbitrary zero, but 10 degrees, 20 degrees centigrade isn't necessarily twice as hot as 10 degrees centigrade. So that's what we call there's no true zero. However, there is a temperature scale with the true zero, and that would be Kelvin. And then we have ratio data. This is data with the true zero. So where, things are multiples of each other. Within ratio, you have continuous data and then discrete data. Discrete data is count. So it can be 1, 2, 3, but it can't be anything between that. So for instance, if you count the number of leopards in a forest, people in a classroom, you can't have 2.5 people. It'll always be a whole number. Continuous data, on the other hand, can take any value between 0 and infinity, because, for instance, weight, length, the number of decimal points it takes is only subject to the precision in your measurement.
Just to say, to really understand the difference between interval and ratio, which can help also, is to say, for ratio data, when it's zero, when your variable is at zero, that means you have none of that variable. That's the main difference between the two. So if length is zero, you cannot go below that. Zero means there is no length. And that's just to be sure to understand the difference between the two. 0 temperature Celsius, temperature can go below 0 actually if you measure in Celsius, but not in Kelvin. That's the main difference. 0 Kelvin, there is no temperature, no entropy. And the kind of stats you will use will be different, whether you're dealing with interval or ratio data. So, right, so now we can move on to the R environment. So the main kind of software that we're going to be using for this course and what is used a lot for stats in general. So some of you are already familiar with R, but not everybody in this class. So just to give you a brief overview, the R language, it's a software, it's a computer language. It has been tailored specifically for data analysis and statistics. It was developed by statisticians. It is used by scholars and it is used in research and development, if you are wondering about some of the applications. So obviously, if you're working in academia, it makes a lot of sense to learn R because it's a common language. Not only it is used for stats, so it's very efficient for that purpose, but also everybody that you will speak with or share work with, they are going to speak the same language, which is the R language. It's quite difficult to learn at the beginning, supposedly. Like, so if you already know, let's say Python, I don't know myself, but apparently is easier to learn as beginners. So R demands a little bit more work at the beginning, but you know, eventually you get there. R is also well known for its beautiful figures. So for research, that's also a very good asset. Because if you want to write a report or write a paper, you can make beautiful graphs that illustrate, you know, your data and your results. Another big advantage of R is that it's free and open source. It's part of a project called the GNU project. You can look into this if you want. It's community driven. There are many packages that have been developed by scholars over the years. The main repository for it is the Comprehensive R Archive Network, also called CRAN. So you can, you know, depending on what you do, let's say, you know, some people mention again wanting to learn capture and recaptures. There are several packages that will allow you to do this. Some may be better than others. Some may have function that others don't, and most of them you'll have. You can download from the CRAN library. Which you can do through R itself. You don't have to, you just need to install R and you can have access to this CRAN library. And of course, you'll need an internet connection because it will download from there. CRAN is not the only place where you can get packages. You can also, you know, to give you a couple of examples, there's RForge, there's GitHub, which you may have heard about. We won't talk about these. We probably won't even use packages from there for this course. But just so you know, CRAN is not the only place, but it is definitely by far the one you may be using the most. Okay, so if you download R, which you would have done for this course, you get a console essentially. So this is the R environment, right? But to help you work with R, you can download what is called an IDE, an integrated development environment. This will simply facilitate your work. RStudio is not the only one, but the one we'll be using here is RStudio. It's a very popular one as well. So I will just go on and show you what it looks like and to show you how to use it. Let me move on to R, which is there. Okay, so you can ignore these. I'll just remove them. Okay, so if you open RStudio with nothing in it, I will just also clear this, and then you get to see exactly what you'll have. So first, here is the main console on the left-hand side, right? It tells you the version of R that you have on your computer. So bear in mind, RStudio cannot work if you haven't installed R. RStudio is just an interface, right? So you need, so you're gonna need R installed, and of course there are different versions. I think this is the latest one, 4.0.2. But if you wish, you can of course use different ones, right? You can download a different version of R and it will also run, right? RStudio should be able to identify where to locate your R anyway. So that's for the console, that's R. This you can write code here, you know, yeah, I can write hello world and it will return hello world, right? I put quotation marks because this would be treated as a character string, right? But I'll explain more about this later. When we write code in R, so R, this is the way it works on objects. So you can create objects through code. I can give you an example here. I will call an object, let's say called hello, and no quotation marks, and here I will put quotation hello world. If I don't put these quotation marks, R will not understand that I want to treat this as a character, you know, like a series of characters. If I don't put the quotation marks, R will return an error. I can show you actually what happens. Return an error because it has an unexpected symbol. It doesn't understand like having these two words separated by a space. If I had only one word, actually, R will think that I'm looking for an object that already exists. So hello is trying to assign, it's trying to create an object called hello and assign. So this is what the arrow is for here, less than and dash, and trying to assign this again, hello. If I put quotation marks, R will understand that it should create an object called hello and assign a character string, which is hello. I can make this longer if I want. So here I will overwrite the object hello and call it hello world. Okay. I can call this object again, so I can write it again this time. If I press enter here, R will simply return what this object is, and I get hello world. It is here in my environment. So the top right window in RStudio shows you all the objects that you have created and what they are. So the object hello here is a character string called hello world. I could do the same. I could make another object called number. Okay. Again, I use the assign symbol here, the less than and dash, which is basically an arrow, and assigning, let's say, the number 1. Okay. And this time number is a number, and says the number 1. If I type number again, the console will return 1. Okay. So here I have all my numbers. Very good. The last window here is you have different tabs actually. If you have a plot, the plots will be here. Also, if you look on the packages tab, you will see all the packages that have been installed. The base R, the R that you will download, will come with packages that are already there, so you can use them. You may have to, I don't know why this is loading for so long, but you can call a package that is already installed. So here are my packages, the ones I've already installed in the past. So the list you have might differ a little bit from mine because I've already installed quite a few packages over the years. Anyway, so this is just the list of all the packages that are available. They are not loaded at this point. This is why the boxes here are unticked. So eventually when we use packages, I can show you how this works. You have also a help tab, which we will use. This is to help you know how to use particular functions. If you don't know how to use a function, you can look at the help here, and I will also show you later how to call this help. You have a files tab, which shows you, okay, what files are in your working directory. This is the first thing we'll do actually, is to set the working directory, which folder we'll be working from. So if you have created a folder for this course, maybe you want to use that as your working directory. If you want to load a data set, for example, that I sent you a data set called Uncia, if you put it in that folder and you want to load it with R needs to know where to look from. And this is why the working directory is important.
So just to reiterate, like, the few basic terminology in R is, one is object, like what Guillaume was saying, and it is just the thing you will be doing functions to. So for instance, if you want to analyze a string of numbers, you can keep repeatedly putting those numbers into R again and again, or you can just assign those numbers to an object and ask R to do something to the object, and then R knows that this object means when I'm asking it to work on data, I am referring to this string of numbers. And function is the things you will be doing to objects. So for example, if I wanted to add two numbers, that plus sign there is a function. So and objects, like you mentioned, can be different types, and a type is called a class. So if it's a number, it's a numeric class. If it's letters, it's a character class. And we'll come to and explain different types of classes as we go on.
I can demonstrate already with these few. If I type class, so this is a function. The functions come with brackets. So you put the name of the function and then brackets. And within these brackets will be the arguments that you need for that function to work. Some functions will need several arguments of different kinds. Maybe we'll need like a vector of numbers, plus you'll need to specify some other things. Basic functions like class, they need one thing, they need an object in between. I told you that you could, if you want to figure out what a function does, you can call the help here. One way to get access to this help documentation is to put a question mark in front of the function, press enter, you don't have to put anything in between within these brackets. Press enter and you'll get the help for this. So the description is, okay, it's a generic function which can be used for an object-oriented style of programming, blah, blah, blah. So there's the arguments. So this part here tells you which arguments can go in that function. The first one is, well, it should be at least X. So that's the usage. There should be at least one argument, which is X, and X is an R object. And what it will do, where is it? In the details, there's some details about the function that you may want to know. Right. So, and what this function it will do is that if I'll remove the question mark for this, I'll put any of the objects. So I have two objects in my environment I could check. If I check the object hello, it will tell me it's a character. So it checks the class of that object. So hello, I know, is a character kind of vector, and it has only a length of 1. There's only one character there, which is hello world. If I check number, the object I called number is numeric. It's a single number. R recognized that this should be treated as a number. The reason it knew this is because I didn't put any quotation around it. Actually, if I overwrite number, oops. So I can override it by assigning it a different thing. I can put quotation mark 1, and this time R will think that this is a character because of these quotation marks. If I do now class of number, I get a character. Okay. Okay, now, as you can see in the console, it's simply like you enter lines of code and you press enter, and then you cannot come back to them. You cannot re-edit them. This is why and this is again why RStudio is so useful, is because we can write a script. We can, and I'll show you how to do this. Before we do this, however, I will show you how to set the working directory, because by default, if you open R from not any particular folder, R will not put any, it will just put a default working directory, not necessarily the one you want to work from. So you want to be sure to work from the folder you think you're working from. To do this, it's very easy. You go to session, the session tab at the top. You can here set your working directory. So one way to do this is to choose the directory manually. This will open this little window. I will want to work from my desktop, and I want to work from the SLN course 2021 folder. So select this, click open, and then R automatically sets the working directory to that, to this particular folder. You'll see the working directory also here at the top of the console. This is the working directory, and I see that this is the folder that I wanted. All right. So this is, yeah, you are free to choose whichever working directory you want with this. You can do this manually. So this, I use the tab, of course, to do this. I could also set working directory manually with the setwd function, brackets, and here I would put the working directory that I want. One thing you should notice, however, if you do this manually, is that unlike Windows, if you're working from Windows, the slashes are forward slashes, not backward slashes. If you put backward slashes to try to set the working directory manually, R will not understand. It will not. It will not work.
Double backslash, it will understand.
Either double backslash or
single forward slash.
Single forward, yeah. Anyway, if you want to simply check what working directory is your working directory, again, it should be here at the top of the console, so you don't. So this is, you can check like this, or you can type get working directory, get WD, nothing else. Nothing. It's a function, so you still need to put parentheses. Like brackets, and if you press enter, it will return the working directory, which should match, of course, the one you have at the top here, and it does. All right, so okay, now for this, we want to create a script. We don't want to work only from the console. To do this, you can go on the File tab. Actually, before we do that, that's something you can do as well, is to create an actual project. So I want to create a new project, let's say. I created a workspace here. I don't want to save it. I just want to start from scratch. If you create a project, you can choose an existing directory, of course, instead of creating a new one. By default, R will choose your current working directory, but you can choose a different one. I will just go to SLN. I'll go to the same one and create a project with this working directory. So if I save anything from this project, it will save it in that directory. Okay. Okay, so yeah, by default, R is loading all the scripts that are in my folder. Okay, so you know what? I will do this again just to demonstrate. Okay, so let's do this again. I create a new project. Existing directory. No, I will create a new directory. New R project. The name of directory will be, I'll call this new project. And as a subdirectory, so by default, it will put it as a subfolder within the folder I'm working from already, which is fine. Otherwise, you could simply browse the main folder you want. So if I go back again to the SLN course, it will create a project as a subdirectory of that. There we go. So now we can see that the working directory now is within the folder SLN course 2021 in a folder called new project. Okay. Okay, so this is just to demonstrate how to create a project, but what we want now is to create a new file, and we want to create a new R script here. Another way to do this is to simply click on this plus and blank page here. So now we have a script, and the script is going to be useful because it will allow us to come back on it. If we run any line of code from the script, and let's say we made a mistake or we want to make small changes, we can rewrite the script and rerun the entire script as a whole. which you cannot do through the console. If you write code in the console, it will run this line and then that's it. You cannot necessarily like edit what you already did. Okay, so let's create a script. The first, the one good practice is to annotate your script so you know what you're doing. Some people say that your worst collaborator is yourself 6 months later, because you will relook at your code and you didn't write down anything about what you're doing. It's just lines of code and you cannot make sense of it. So, so you're not making your life easy. So to annotate your script, you can you can use hashtags in front of design. If you put a hashtag, this will not be run as code. This is just text. So it might as well not be there, but it is useful for you to have it there. It's annotation basically, but nothing. This is not code that will be run. If there's a hashtag at the beginning of a line, R knows that it's not code. It's just annotations. So I'm just going to give a title to my script here. I will just put SLN course 2000, so module 12, I think. On a separate line, I will say, I will put the date 03/06/2021. So if I try to run this, and one way to run is to highlight the code that you want to run, you can click run here, or alternatively, you can do Control Enter. And Control Enter is basically a shortcut for doing run here. So either you select the code you want to run, or you just go on the line that you want to run and click run. Okay, and as you can see, nothing happens here. Well, it returns these lines, but nothing happens with these lines. So there's no code associated with this. Okay, the first thing we're going to do is create. So this is where annotation comes in handy. Is that here I am saying what I'm doing, and I'm going to create a vector, which I'm going to call number of plants. Number of plants. So this is a small exercise that we're going to do together. I asked a few people about the number of plants that they have in the room they're standing right now or in their home. So there's 5 people that gave me a number, and we're simply going to put this as a kind of create data from this, try to create a data set from this. So I'm going to create an object called plant. So I'm going to use the assign symbol here, less than and minus or dash. And I'm going to use the C function. The C function, C stands for combine. So I'm going to combine several entities that I will put in a single vector. So the plant, I want this to be numbers, right? So when I demonstrated earlier, I created an object called number, and to which I assigned the number 1, or a single number. The C function, the combine, allows me to have several numbers put together into a single vector, a single object, which is going to be called plant here. So the first person had 4 plants, the second had 2, and as you can see, I'm separating these values by a comma every time. Then we had 0 plants, 0 plants, 0, and someone had many plants, 24, okay? 1, 2, 3, 4, I think that's it. 1, 2, 3, 4, 5, 6. Okay. So there was 6 people. So 6 values. If I press enter, if I run this, you will see what happens. In my environment, now I have an object called plant, and there's 6 numbers from 1 to 6, and I can see it's numeric here, and the 6 values that are in that object. I can call this object on the script. If I simply write plants and I press and I do Control Enter, or I highlight this and do run, it returns that object, that vector, and I see that it has all these 6 values. Okay. If I did class plant, you will have guessed from what we did earlier, it will return numeric. It's a numeric vector. R understands that these are numeric numbers. That it should store these values as numbers within that vector that I call plots. I'm going to go ahead and create another vector. Create another vector that I'm going to call names. I want corresponding names for these numbers here. So I can have a data frame in the end, maybe one column will be the names and the other will be the corresponding numbers for that person. Okay, so let's go and create an object called names. Again, I'm going to use the combine function, and I'm going to go ahead and write down the names of the people that gave me these numbers. The first one was Fai. Second was Ranjana. Third was Tan. And then it was Tashi. Then we had Flavia. And finally, we had Aliana, who had many plants. She had 24 plants. So R will create that vector, and it will keep that order. It will have Phi as the Phi. Sorry if I'm mispronouncing your names. As the first person, so the corresponding will be 4. So it will be all in the same number. It will preserve it will preserve the order into which I'm creating this vector. So if I run this, so I go on this line, or I could also just highlight the entire line and do Control Enter. And now you can see, oh, by the way, that of course the console is, everything that I run is going to be run in the console, right? It's kind of transferring this into there and running it. And now I have a second vector. This one is going to be a character vector because I put these quotation marks around every value. And I have 6 names, right? Which correspond to the 6 numbers. And again, remember, the order is preserved. So it's not going to do anything like reordering alphabetically or anything like this. It's just going to preserve the order that I assign. And of course, yeah, again, similarly, if I put names and I want to check what names is, I can run this and it will call that object and return it in the console. And I can see I have all 6 names. All right, okay, so of course at this point, these are 2 separate objects. You know, they're not fused in any way. So I'm going to try to combine them. Combine the vectors. And notice every time I'm annotating what I'm doing. Of course, I don't have to do this. I don't have to. These hashtag lines are really not useful, right? They're only useful because it's text. It's for me to know what I do. If I look at this code 6 months later, I know what I'm doing. I know that here I'm creating a vector, number of plants, and here I'm creating another vector, names. Of course, this is maybe not the most useful script and the most useful annotations, but yeah, for more complex work, you might really want to have annotations to know what you're doing. Otherwise, you will look again at your code and have no idea why you did certain steps. Okay, so I'm going to create a new vector now, which will be the combination of the 2 vectors that I created before. I'm going to call it plant data. It's going to be my entire data, the names and the numbers that I want to put together. And I can simply use the combine function again to simply combine these 2 vectors. And I will again use the function C, the combine. And first I will want to put the names, comma, plant. So if I run this, it will simply combine the first vector with the other one. Okay, so what do we have? If I look at plant data and I run this line, now I see that I have 12 values. So 1, 2, 3, 4, until 12. By default, R coerced this entire vector as character because while we can put number as character like we did at the beginning, remember the number 1, I put quotation marks around the number 1 and it became a character because R knows that if there's quotation marks, it should be treated as a character. We cannot turn a character into a number, that would make no sense. Like phi, we don't know what number that should correspond to, for example. So by default, we're trying to like put two different kinds of vectors into a single one. R is gonna try to, R cannot have a mix of classes within one vector. It will want to have a single class, which is why it's coercing, it is forcing these numbers to be characters. So if I do class, I want to check the class of plant data. So here you see I'm running this from the console directly. So I just want to check this. I don't need this to be in the script at this point. So I'm just going to run it from the console itself, press enter, and it does tell me this is a character vector, which of course is not ideal. I would like to have the numbers as stored as numbers, hopefully. But we'll see how we can go about in doing that. The other thing you may have noticed, this is simply just a series of entities. It's a vector, but it's linear. It has only one dimension, right? From 1 to 12. It's just 12 things that are put into a vector of length 12, right? But if I want a data frame, if I want anything that resembles data that I can use, ideally I would like two columns. I would want a two-dimensional object with a certain number of rows and a certain number of columns. Ideally, a column that we call names and a column that we call number of plants. And for each row would be each person and their corresponding number of plants. And that will be data that we can then use. There's two main classes of objects that we can use to achieve this. The first one is a matrix. A matrix is by definition a two-dimensional object with a certain number of rows and a certain number of columns. This is kind of what we want. Only problem is that a matrix really only works again with only one type of data. So the entire matrix is either going to be characters or numbers. A more useful class of object is a data frame. A data frame can have each column as a separate class. So one column can be numbers, another one can be characters, or then there's other classes that we haven't talked about yet. There's factors and so on. But let's first create a matrix. So this will be a matrix. I'm going to just put this as the annotation. I'm going to create a new object that I'm going to put plant.matrix this time to convert this single vector into a matrix. Again, assign. Although before I do this, so I'm going to call the function matrix, but I don't know if I don't know how to use it. Let's remind ourselves. So I'm going to put quotation mark matrix in the console here. If I run this, remember this will call the help file for this function. So simply to again demonstrate how to use this help documentation. So matrix is a bit more complex than the function we used before. This time we'll need an argument called data. And in the usage part here, for some of these arguments, R will put a default. By default, the data will be NAs. Okay, if you don't specify what the data is, R will simply put NAs. We can specify the number of rows. By default, it will be one row, and by default, there will be one column. If we input data, R should know in which order to put it. Should it assign the data in the matrix by row? So should it fill the matrix with data by row or by column? By default, it is by column, which is why the by row here is put as false. Dim names is simply to assign actual names to your rows and columns. So you have column names and row names. By default, the columns and the rows have no names. All right. The arguments, so in the argument section, you have a bit more detail on what these arguments should be. So from n row, it should be the desired number of rows. So you would have guessed that here it should be a number, right? N row should be a number. If you put a character, R will not understand because it's expecting a number. So let's go ahead and try to create this matrix. So the matrix function is simply matrix, open brackets. The data, so if I put nothing, let's see what happens. Oops, well, here puts me an error. It doesn't find the function because I did a typo. I forgot the I. So if I run it as is it like this, it does create a matrix. It works, but it creates a matrix that is empty. So if I call plant, oops, plant matrix, oops. This is what the console returns. It returns a matrix with one column and one row with NA. And remember, these are the default, remember? So this is what R does by default if I don't specify anything. So now I'm going to come back to the script. I want to modify what I did so that I can actually have what I want. So the data this time, so the data argument, data is going to equal my plant data, which if you remember is a single vector with 12 values. I want, so 12 values means I want 6 rows and 2 columns. That will be 12 cases, right? So n row will be 6 and my n column will be 2. 6 rows and 2 columns, in total 12 values, right? In a matrix. So if you look at this, of course, I want this to be put by column. I want so it will, what R will do is it will look at this vector and assign it into the matrix. If it does it by column, it will look at first column, it will put phi. So first row of the first column will be, it will assign the name phi. Then the second row will be Ranjana. The third row will be Tan, and then so on. And then it will move on to the second column. If I did put by, like if I put by row, so remember this is one of the arguments in that function. If I put by row equals true, this is what's going to happen. I can look at the matrix and it assigned it by row. It did first the first row, then the second row, and so on. You know, using that vector in the order that it is. So that doesn't work for me. It's not what I want. I want the first column to be the names and the second column to be the numbers. So I'm simply going to put false here, which is a default. So I could actually leave out this completely because that's already the default, right? And this, but I will simply write it just so that it's explicit what I'm doing. And if I run this now, I end up with a matrix which has the first column as the names and the second column as the number of plots. All right. Another very useful function is to look at this. It's called the structure function, str, and I can look at the structure of an object, kind of similar to class, but it's a bit with more information, essentially. So if I want to look at the structure of plant matrix, I put structure in brackets the object which I want to investigate. If I run this, this is what I get. I get, okay, this is a character type. So it's a matrix of type character. There are 2 dimensions, which is you have the square brackets here, which indicate these dimensions. First dimensions is 1 to 6. So these are the rows. And the second one is going to be the columns, 1 to 2. By default, R will be, the first value for the dimensions will be the rows and then the columns. And then it gives me all the values that are in there. And this is what it tells me. It is double character with 1 to 6 rows and 1 to 2 columns. Okay. I told you you can check what your object is. What is your object? So if I put if I use the function is matrix here, and I put plant matrix, it will check whether plant matrix is a matrix or not. And what it returns here is, it tells me, yeah, it's true. It's a matrix. Very good. Okay. So I hope so far it's pretty clear. So we, just to like recap the steps that we did, we created an object called plant, a vector with numbers. We created an object called names. So a second object called names, which will be a character Okay, sorry. Yeah, the structure function. I will get to it. We create a second object called names. We put these two objects together with the combine function here. That we call plant data. So this is a single vector with the two vectors combined. By default, R put this vector as a character vector because it couldn't really do otherwise because there's characters in it as well as numbers. And then from this, using this single big vector called plant data, we created a matrix. So the data would be here, and we want to like spread this data in the table. So a matrix is essentially a vector with two dimensions, like a certain number of columns and a certain number of rows. And it will just spread this data in that table. And we'll do it by column because we put by row equal false. And we put that we said that there will be 6 rows and 2 columns. Okay. The structure function that I use is simply to inspect this object. It will tell you what structure it has. So if I rerun this again, it tells me what kind of data is there. It's character data only, which again, at this point is not ideal. We don't really want that. It tells me that there is 6 rows and there is 2 columns. Okay. Dim names we can use also. It's another argument. By default, it put the dim names essentially is to determine, to tell R what the names of the columns and what the names of the rows should be. By default, R, as you can see, because we looked at the matrix here, it has no names. It's this is column number 1, column number 2, row number 1, row number 2, and so on. Okay, but if we want, we could actually put names for this. Okay, let's do that. Actually, we can dim names. So I will add to that function here. I will simply add an extra argument here called dim names. Dim names. Okay, if we look at the help here, dim names, it tells me it should be a list, which is another kind of object in R. I will not explain now what this means, but essentially because R is expecting a list here, I will simply write list. Also, I think I'll put this on a different line. So I pressed enter here to put this argument on a different line, just so that it doesn't exit the screen, so that we can see all the arguments together. But if you run this, it will still understand that it should count the first line as well as the second line. Okay, so it's going to be a list, and there's going to be, R is expecting a list with 2 things in it. It will be a list with first the row names and then the column names. And it tells you this in the help file. Dim names is going to be a list of length 2 because the first chunk should be the row names and the second chunk should be the column names, respectively. It tells you what is expected. So it will be a list, and the first thing will be, and I can use again the combine function inside. It will be actually I can go ahead and call the row name maybe already with the names of the people. So I can just put names here, and it will know that. So the first argument should be the row names, which names we already know is a vector with 6 characters, which is fine. So it will fill these 6 row names as the names of the people. And we'll use that vector here. The second one should be obviously a vector of length 2 because there's only 2 columns. So for this, I will actually put a C here. I will use a combine. The first column names will be names. So I will names, and the second one will be n plants, the number of plants. Okay. I can run this whole thing, so I can highlight this and run it, and we can see what happened to the matrix. Now, if we put structure, now it has name, so it tells me, okay, this is still the same as we had before. It's a character with like these 6 rows and 2 columns. the list of all the data that we have in that matrix, but then it tells me, okay, it has attributes. It has, because I did label the columns. The first column is a character with 6 names, and the second one is another character. Sorry, this is the row names, and then these are the column names, and there's names and there's prompts. So it kind of gives me an idea of what I have in that matrix. Okay, don't worry if you're a bit lost, because we will be using R a lot and we'll always be taking it slowly. So even if things are not clear right now, they'll probably become clear later anyway. Okay. So at this point, just, yeah, again, the main thing is to understand that in R, we're creating objects, and we can use these objects later within functions, or we can inspect these objects. And all the objects that you have created are in your environment. You can see what you have created here. And it kind of tells you what kind of object you have, essentially. Okay. So Anne, do you want to add something to this?
No, I think you pretty much covered it. Just so Flavia is having a little trouble. Flavia, can you share your screen once just so we can see what's up?
I think it might be difficult for everyone to share the screen.
Because she's not seeing any options on top.
Flavia, can you unmute yourself and maybe tell us what the problem is? Maybe some people have the same problem. We can quickly try to troubleshoot that.
Sorry, it's a silly problem. It's just that my console is taking all the space, and because I don't have the same window as you, you have this console terminal window below, and you're typing over.
Right.
Oh, okay. I think I just found out what's the problem.
So you have to have this window, the script here. You basically need to like create a script here. So you can either click here in this corner, which is to create a new script, or you simply do a new file and a new R script. And this will give you this extra window here with the script. Otherwise, what you'll have is
yes, I did something very wrong. I get it now. I did
okay, perfect.
From the beginning, I did it wrong. I get it now.
Okay, I hope everyone is fine with this as well.
So no one has any trouble having the script. No one else has the same problem, right? Everyone has a script window and the console window open. Okay, I'll take silence as yes.
Yeah. Okay, so matrix is all right, but actually, yeah, we could, so how about we want to create now, let's try to create a data frame from that matrix. Okay, so we have created that matrix, but we would ideally like to create on a data frame. The idea behind working with a data frame is that a data frame can accommodate, like every column can be its own data type, which is great because with data frames, we might want the column to be characters, like, you know, these categorical variables. Maybe we want another column to be numbers, you know, so we want R to recognize these as numbers. And that's what we're going to do here. So we're going to just convert this matrix into a data frame. Again, data frame is the kind of object we'll be using the most in R when we do data analysis. And don't worry, you won't always have to do these steps, of course. From like here, we're really starting from scratch. We're manually like creating data in R, but very often you'll be importing data directly from maybe an Excel sheet that you have created to where then that's where you keep your data. And R can automatically import that data as a data frame. So obviously you won't have to do all these steps that we're doing now. Right now, we're really working from the bottoms up. We're like creating different vectors. We're trying to put these together into a matrix and converting that matrix into a data frame. And this is really just to get a sense of how some of the functions work. We don't have to do this every time, of course. Okay, so let's try. So we're gonna try to, so we're gonna just call this plant df for data frame. And now we'll just do this. We'll just do as data frame, which is another function in R. And in brackets, R will just want some objects. So if we have a matrix we can simply put that matrix in here. So plant matrix, which is our matrix, the matrix that we have already created. And it will very nicely convert this matrix into a data frame with this as data frame function. And again, we could have avoided that step of creating a matrix simply by using the data frame function from the beginning, and it would have simply, which is similar to the matrix function in many ways. You can, if you're interested, you can just look at the help file for the data frame function like this. And it will, in the same way that we looked at how to create a matrix, here it tells you how to create a data frame, which is a bit different. But here we already have this data in a matrix, so we don't want to start again. We simply use that matrix and convert it to a data frame with this as data frame function. So let's have a look at what it looks like, this plant data frame. So I'm just going to run this line, and now we have this. It looks a lot nicer. You can also view it if you click in the environment. You'll see that the data frame looks a bit different from the matrix. There's an arrow here that you can click on and expand, which you cannot do with the matrix. If you click on this, you will see what's happening. It tells me that first, next to the name of that data frame, it tells me I have 6 observations with 2 variables. The first, and it tells me what these variables are. The first variable, so the first column, is called names. It is a character. So, and it has these characters here. It gives me the first few characters. And nplants is another variable. But it tells me it's also a character, which is not ideal. I would like these as numbers, ideally. And it tells me the characters that are there. If I actually click on this line, see what happens. It's actually opening a tab here, and I can have an overview. I can actually view that data frame, which can be very useful, you know, if you want to inspect it. You can see, of course, that I could also inspect it. We can't. Sorry. Yeah, you can also inspect it in the console by just typing the name of the data frame, and then it will just print it here. So you can also have a look at it. Okay, someone is asking, what if we don't want names again? Because yeah, names are repeated now because I specifically put the row names as names, but we also have a column called names. This is really just for demonstration. So we could subset that from that data frame and maybe remove that column because we already have the row names. Let's do that. Okay, let's subset the data frame. And exclude the first column, right? Let's try to do that. Okay, so again, we're going to overwrite the plant data frame, okay? So I'm going to again create an object called plant data frame, which already exists, so it will simply overwrite it. So I will use the plant data frame, and I want to keep only one particular column. There are several ways to do this. To refer to a column in a data frame, you can, and this is obvious when I looked at the structure. You see that in front of every, sorry, this was the plant matrix. Oh yeah, sorry, I didn't look at the structure again. Let's look at the structure as well. So if I put str and then plant data frame, that's what it tells me. So okay, this is a data frame. That's the kind of object it is. So if I did is matrix on that object, if I wanted to check whether this object is a matrix, let's try. Is matrix plant df, it will tell me false. It's not a matrix, it's a data frame. If I put is data frame plant df, and it tells me true, it is a data frame. Very good. So, and from the structure, when I run structure here, you see that there is a $sign here for names, for my column called names, and another $sign for nplant. And that's actually very handy. It tells me that I can use the $sign to refer to these columns. So if I put plant data frame and put a $sign next to it, it will even it will give me a list of the columns that I have in that data frame, which is very handy. What I want to do is I want to only keep plants. So I will simply use that. it put these quotations next to it because I have a space here and R doesn't like that. So it wants to make sure that this entire thing is my column name. This is why it's automatically putting these quotation marks. It will not do it for the other column because there's no space in it. Names doesn't have space, so you don't need these quotation marks here. But I will put $, and then select. I can click on it. This, and if I run this, it will override PlanDF with that, so that it's only that column. And if I look at it again, now we'll see that it is actually just a vector. So it's not a data frame at this point. If you use the $, it will actually only refer to this as the vector form. So, which is not great because I've converted my data frame to only a vector, which is not what I wanted to do. So this is how you can do this. There's another way to refer to your column is with square brackets. So I'm just gonna delete this part because that's not what I wanted to do. And I have to find the square brackets on mine here. So you see these square brackets here. Here I can refer to parts of my data frame, but by using the square brackets, it will preserve that data frame object. So it will not change it to another kind of object. It will still be a data frame when even if I subset from it. This square bracket, so the data frame has 2 dimensions, right? I could actually check this with the dim function. If I call dim with the name of the data frame here, run this, it tells me, oh, sorry. Because now PlanDF is no longer a data frame, which is why it tells me no, it has no dimensions. So I'm going to rerun this again. This is the step where I took the matrix and put it into a data frame. So I'm going to override PlanDF so that we're back to what we had. Which is why, again, if you can appreciate that it's useful to have this script because you can come back to what you did and rerun parts of the script. So I rerun that line. So I did that step again of converting the Plan matrix object, which still existed, which was still in my environment, to get back to the data frame I had. So now if I run dim PlanDF, it will tell me, okay, the dimensions are 6 and 2. The first dimension is the rows. The second dimension is the name of the columns. Always, by default, R deals with these dimensions like this. The first is going to be the rows. The second one would be the columns. All right, which is why in this within the square brackets, this is what you will do. So there's 2 dimensions. So let's say I put 1 here and then 1 again. This means I want to extract the first row and the first column. So this will be a single number. If I would simply run this, this is what will happen. It will tell me, okay, well, you want me to take the value that is in the first row and first column, and that's 5. We can actually look at PlanDF, and you see first row, first column is 5. So it returns this. Okay. I could refer to the entire first row by simply removing the column index. So I leave that blank, but I still need to keep the comma here. And now this is going to refer to the entire row. And now I have, it's like a tiny subset of the data frame. So it's a tiny data frame itself, which has only the first row, which is 5. I could refer to the first 2 rows by putting 1 and 2, like 1, 2, 2, with this semicolon here. Now, if I run this, I get the first 2 rows. I could extend this to make the row from row number 1 to row number 3. And if I run this again, I will get now the first 3 rows. Maybe I want just the row number 2 and number 3. I could replace, so I put from 2 to 3 and so on. I think you get it. Okay, but as we said before, we just want to get rid of the first row, of the first column. So we want to keep all our rows. We don't want to delete any of the rows. So we will leave the row index blank so that we keep all of the rows, and we will simply subset the second column. So I want column number 2 here. So if I do this, that's what we'll return. It's going to be, well, let's have a look. Plant df is now, oh, actually, wait, it's still a data frame. So I'm getting lost myself. Okay, I thought we would have another data frame from this. So what we can do, okay, it's still returning a NeoVector. So I'll just put as data frame in front of it so that we keep this data frame kind of structure. So I overwrote it, so I rerun this, rerun that, okay. So now when I look at plant df, we have a data frame with only the numbers, but it overwrote everything else. So, my bad. Okay, anyway, it doesn't matter. Okay, so I can manually assign row names to this. So now we lost the row name, which is not ideal. So we now only have the numbers. I can simply put row names of plant df. So this is another function which will allow me to name these row names. And I want these row names to be my vector names, which has all the names, right? If I run this, you will see, and now looking at plant df, that now I label the rows. The column name also has changed now, because I doing that conversion process. So I will just reassign this column name. There's a function called call name of plant df. So it's a function that does exactly the same thing, but for column names. You'll notice that one has a dot in between row and names. The call name function doesn't have a dot, doesn't really matter, but and I want this, we said, to be a vector, and the first, oh, actually it's only a single value, right? It will be n plants. So now if I look at my data frame, plant df, I have essentially what I want. All right. Okay, I think this is about it for now. Some people have questions, I think. So let's see. Fire is asking, okay, when trying to run row 29, I get a message error in row names. Okay. So Phi, if you get an error message at the time when you try to run line 21, row names, it's because plant df at this point, if you look at your object plant df, you'll see it is not, it's neither a matrix or a data frame. It's probably because it is at this point just a vector. So you can return to maybe this step. So you create a data frame, and then when you run this line, it should work. Let me know if it does. The last thing we'll do for now, because we are going to run out of time if we spend too much time on this.
So just to add, in order to check, just either run class with your object name or dim object name, so it'll tell you what it is.
Yeah, I will put this in the script as well. If you want to check what so it's going to be the function class, and you put in your object. So if I put class plant df, it tells me it is a data frame. If it tells you that it's not, maybe, so for example, one of my other objects that is not a data frame is names. It's just a vector. If I put class of names, it will tell me it's a character. So it's a character vector. So this row names function, it will only work on a matrix or data frames. And you can check this, if you have any doubt, you can check this with the help file. Again, you can, so checking the function row names with a question mark in front of it, it will tell you, okay, row names there's going to be one thing in it. It can only have one argument, one object within those brackets. And it tells you that X, or the object you put between the brackets, should be an object of class data frame or any other class for which a method has been defined. So I think for matrix it also works because it can take row names essentially. But a vector, a simple vector like we had, cannot take row names is because there's no rows, basically. I hope that's clear for everybody. The last thing I want to do, if we have this data frame, so the only thing, oh wait, I think I know something. Yeah, if you run this code in this order, all of it in the same order, you should end up with what you want. I'll just put it in the chat in case some people have added extra lines or have not been able to type the code like I did. So I'm putting this in the chat for everybody to see.
And we'll also save it and put it in the group.
Yeah, at the end of the session, we will save the codes. We'll make it available for everybody, but just for everybody to maybe have access. You can literally just copy and paste this entire code. You can put in the script and run everything, and you should end up with this exactly the same objects that I have. Okay. So yeah, the last thing I want to do is add another column, maybe just to get more information, maybe like an extra variable. For the people that gave me the number of plants they have in their rooms, can you give me the country you're from? And we'll just make another vector with the country names and add this as an extra column in this data frame that we already have. So, okay, we have Faye is from England, or is in England. We have, so only the people that gave me the number of plants. So Faye, Ranjana, Tan, Tashi, Flavia, and Aliana, if you can tell me where you're from. Okay, Aliana is from Saudi Arabia. Ranjana from India, and Faye from England. Tashi is from Bhutan, and I think we're still missing Tan. And yeah, I think Tan. Bhutan. Oh, okay, Bhutan as well. Okay, cool. Let's do this. So let's create another vector called countries. Okay. Okay, we'll just name this countries. We'll assign, or just country, maybe singular country, and we'll create another vector again using the combine function. And this will be just a series of characters, which will be, okay, the first one I think was, okay, Faye. We said Faye from England. So we'll put England here. So I'm respecting the same order, right, that we have on my table, because otherwise they'll be mixed up, right? The second one is Ranjana from India. Third one would be Tan from Bhutan. And Tashi also from Bhutan. Notice again, I'm putting quotation mark because these will be characters. I want these to be treated as characters. If I don't put quotation marks, anyway, R will send again a message saying, oh, I can't find this object that called England. Okay, so we have now 1, 2, 3, 4. Flavia is from Brazil. So much diversity. Oops, Brazil. And lastly, Aliana from Saudi Arabia. Okay, so we making this vector. I'm gonna run this line. And we end up with, okay, a country vector. Okay, we check it has 6 values, so we're good with the country names. And we're going to create a new column in the plant df data frame, which we're going to be countries. So and we can simply do this, plant df, and we're going to refer to the column called country. So there's at this point, if I run this, it will give me an error because it'll tell me, oh, it's null. Because there's no column called country at this point. But I can assign something to that column, that new column that doesn't exist yet, and I'll just put country, which is an object, the object I created. And if I run this, you'll notice that if you inspect PlantDF, it now has an extra column called country, and with the countries matching the name because I put them in the same order. Yeah. Okay, I'm kind of wondering if it's worth kind of. Yeah, I think that's fine. So there's, just to be sure we know how to kind of manipulate these data frames, the $ is one way to refer to a column in a data frame. There's actually two other ways. One I already mentioned is with the index of rows and columns. So if I want to, oops, I'm just going to create another column also called, maybe I'll call it country 2, with the same countries, but just for you to see like how else we can create a column. So with the square brackets, I'm referring to like which dimension I want. Remember, the first index is the row on this blank, so I'll just leave that blank here. Then the comma, and then this will be my column index. I want to create a third column, so for now I only have 2. So this will be column number 3, which I will assign the name country. So let's see what happens if I look at it. Okay, now I have an extra column also with the country names. You'll notice that it has no names though, because I only said, okay, it's going to be column number 3. It put by default V3. We can override this, and with that function, call names that we already used. And this we can call it something else if we want. There's another thing we can do to refer to another column so again, it will be with the square brackets. Again, leaving the row index blank because we don't want to change the row names. We don't want to create extra rows. And instead of an index, instead of a number, we'll give it a name already. So we'll call this country 2. Okay. So I just put this in quotation marks, so this character. So R knows this. That's a name. It's going to be a character. Same thing. I'm just going to use country. And if I do this now, let's look at it one last time. Now it's creating a column with a name because that's the name I gave it, called country. So essentially this line, the line 38 and line 40 are doing pretty much exactly the same thing in 2 different ways. One using the $, one using simply the square bracket form. Okay, I hope this is clear for everybody. We'll come back to this anyway later. So if you feel a bit lost, I think it's okay. You can come back to this script later anyway. We'll save it somewhere. And yeah, so this is just a general intro of how to create vectors, how to create a data frame, how to kind of like inspect your data frame and how to modify it, and also subset it. So what we did before was to subset it by only having a single column. Actually, right now I have a data set with 3 columns with the country names. I don't want that. Let's just subset from it again one last time, so that I really have only the columns I want, so only the first 2. And to do this, I will overwrite PlantDF by assigning something to it again. So I will obviously subset from PlantDF. If I run this, it will just replace PlantDF with PlantDF. So obviously it's nothing will change. But if I use the square brackets here, I can subset it, but okay, I don't want to subset the rows. So again, I will leave the rows blank. And maybe I want the first 2 columns, column 1 and 2. So you can do this with a semicolon here. So we'll subset with column from column 1 to 2. You could also selectively select column 1 and 2 with the C function. And instead of so I'm going to put a dot here. So let's say if I put 1 and 3, this will specifically subset and keeping only column 1 and column 3, right? Instead of column 1, 2, 3, which is why it can be useful to do it this way. If I run only this, you'll see that that's what we get. We get column 1 and column 3, which is called V3. I want column 1 and 2, so I'll replace the 3 with the 2 here, run only this, and you'll see that's what we get. Or I could, yeah, again, I could simply put 1, 2, 2, which is exactly the same. Run this, I can look at plotdf again, and I get the data frame that I wanted. And that's it. That's how you can create data. That's how you can modify your data frame, creating a new column and subset from it. Maybe you want to get rid of maybe the first, I don't know. For example, we could say, oh, Aliana is an outlier because she has so many plants. So we want to exclude her from the data set because she's making everything screw with the jungle that she has for a room. So I could subset that if I want. For example, and that I could do here. I would have to want only rows from 1 to 5, excluding row number 6. If I ran this, I will run only this so it doesn't overwrite this object. But if I just select this part to run this, it will return what would happen, and I would indeed end up with a data frame that doesn't have the last row. And that's it. Or maybe I want to exclude anyone that doesn't have plants. Maybe I'm only interested in people that do have plants, and I could subset and instead remove row number 3 to 5. And that would, that is selecting row number 3 to 5. So we end up with only the people that don't have plants. So instead, I think I put a minus. If I put a minus here, I think it works. No, it doesn't work. Oops. So instead, I will selectively have row number 1, row number 2, and row number 6. So essentially, this obviously would remove row number 3 to 5 because I'm only selecting row number 1, 2, and 6. And if I run this, boom, I end up with only the people that have plants, basically. All right, again, this was simply like for some of you that already know R, this was probably very redundant because this is really basic things. But with this course, again, we will obviously, that's one of the main goals is to teach you how to use R. And these are some of the basic things you want to do. Create objects, create a data frame, and kind of subset, manipulate your data frame a little bit. Okay, I think at this point we can just get back to the presentation.
Did we lose him?
I think we did. But in the meantime, I'll just answer that question. Rohit asked, yeah, so you can run it on, you can just select the column and run the function on that column. But I would say it's better to create a separate object because then you can keep manipulating that object instead of having to run it again and again. And we will send the code, we'll save the script and put it up in the group. So you don't have to worry about that.
Hi there. Sorry, I disappeared for a second.
Yeah.
All right.
And so in terms of use, there isn't necessarily much difference. At least in the most basic functions, you won't find much difference between data frame and matrix. It's just that data frames allow you to have character vectors as well as numeric vectors, but matrix is only supposed to be numeric vectors.
Numeric or just character or?
Yeah.
Data frame is easier to use when you have a mix. It's heterogeneous. So you can have a mix of data types in it.
Yeah. And also it's I think the difference really comes into play in more developing and higher functions. The basic functions, there's no difference between them.